Hey folks, this is Mr. Young, and I am going to take you through the idea of point of origin. The question is, can we figure out or find the point in space where blood spatter originated, the place in a room where blood spatter originated? And of course the answer is going to be yes, or you wouldn't be watching this. So this is point of origin. Okay, so let's imagine we have this incident. It's an assault or self-defense incident. Maybe he was carrying his bag and then this mother, she came up and attacked him to steal his bag. Or maybe it was her handbag and he was attacking her and this is self-defense. We have no way of knowing. But anyway, in this case, it's some sort of assault or self-defense incident and she's hitting him in the nose, and that's going to produce some blood spatter, some low velocity impact spatter. Okay, she's punching him or beating him or hitting him, and so the blood spatters onto the ground. Okay, and like we've already learned, those blood drops, because they're hitting the ground at an angle, will have kind of an oval shape. Okay, all right, now let's talk about math for just a moment. I know that's what you really want to hear. So we've previously we used the sine idea. Sine is opposite over hypotenuse, to figure out the angle of impact of some blood drops. Whoops. So previously we used sine in that formula for figuring out the angle of impact. Okay, now we're going to add one more idea, and that is tangent. Tangent is the ratio of the opposite side of a triangle over the adjacent side. Why is that useful? Well, if we imagine that here's a person, and here's a blood drop that maybe originated on their face, okay, because someone punched them in the face and blood flew out of their nose. Okay, well, if we know the distance from the spatter to the point of convergence, where that person was standing, and then we know the angle of impact by using the sine formula that we already know, we can figure out the height in space where up here the blood spatter originated. Okay, so let me walk you through this. All right, so here's our incident again that produces some low velocity impact spatter. The blood hits the ground, and now these blood drops have been zoomed up so they're easier to see, and they wouldn't really be this big, right? Now let's look at these from above. Okay, this is a bird's eye view of the floor now. This is something you learned at the end of Forensics 1. What you can do is you can backtrack. You can draw lines going backwards along each drop to find what's called the point of convergence. Okay, now these blood drops were traveling this way and this way and this way because you know that the spines point in the direction the blood was going. So what if we backtrack? Okay, using a ruler, we backtrack through this along the long axis of the blood drop, backtrack here, and backtrack here, and we get this point where all those lines meet. If we're lucky, they meet perfectly. Sometimes they don't meet quite perfectly. Well, we call this the point of convergence. Now, you learned this in Forensics 1. Maybe you don't remember that term, point of convergence, but you learned this concept about backtracking along the blood drops to find where they came from. Okay, so this idea of the point of convergence, it's basically like a spot on the floor. The floor is a two-dimensional surface. Okay, it can tell you where people were standing, people were located when the blood was spattered. And so basically, if you find the point of convergence, you know that the blood spatter originated directly above that spot, somewhere directly above that spot. So let's put that idea back into our incident, our assault. Okay, so here's some blood spatter. I'm just going to do one of them now in side view. Okay, here's the point of convergence. We backtracked from the blood spatter to figure out where this guy was standing when the blood was sent flying from his nose. Okay, and now previously we measured a blood drop like that. We measured the width and the length using those special calipers, and we were able to figure out the impact angle. That's something that you have already done. Okay, all right, but now let's take it a little further. If we were to figure out the distance from the blood drop to the point of convergence that we figured out on the floor, okay, we've got this distance here, from here to here, from the blood drop to the point of convergence, and then this is the other part of our triangle. This would be the height where the injury occurred. Now, this height, this spot up here, we call the point of origin, where the blood spatter originated. Okay, it turns out we can just write a formula like this. This height right here is equal to the tangent of this impact angle, which you already figured out by measuring the blood drop, times the distance, which you can figure out by finding the point of convergence and measuring from the blood drops to the point of convergence. So in this new formula, this angle, you figure it out by using the calipers, measuring the blood drop, figuring out the angle of impact. This distance, you figure out by finding the point of convergence, measuring the distance from the blood drop to the point of convergence. That will give us the height. That will give us the point of origin. That will tell us where in space the injury happened, and we call that, again, the point of origin. So here's the idea. By measuring multiple blood drops, you can work out the location in three-dimensional space where the spatter originated. Okay? Why? Well, because this can help reconstruct what occurred at the crime scene. It can help to back up somebody's story, or it can help to refute stories of the suspects, things like that. Okay? All right, so let's just run through this one more time with a simplified diagram, because that last one got pretty cluttered. Okay, here's the point of convergence. How did you figure that out? You did the backtracking through the different blood drops to find the line where the lines intersect. Okay, and where the blood spatter originated is directly above the point of convergence. How do we find this point in space? Okay, well, first we have to have found the angle of impact for each of these blood drops. Then we can find that height by taking the tangent of the angle for each of these blood drops, multiplying it by the distance from each blood drop to the point of convergence. So you can calculate this height a few different times, and you should get the same value each time if all these blood drops came from the same impact on his face. Okay? Again, this is called the point of origin. That's where the blood spatter originated in space. Down here, this is just the point of convergence, where you draw those converging lines. All right, and in your reference tables, we already have this formula. The impact angle is the inverse sine of width divided by length. Okay, this is the new formula. The height of the impact point in space is the tangent of the angle of impact, which you know how to calculate, times the distance from the blood drop to the point of convergence, that spot on the floor that you find by doing the intersecting lines. Okay. All right. Oh, and that is it. Thanks for